Okay, so I want to discuss these questions. It says that a displacement reactions between metals and iron. All right, so it is actually because of the different reactivity. So if one metal is more reactive than the other metal, then displacement reactions happen or occur. So it can be used to determine the order of reactivity of metals such as lead, nickel, and silver. All right, so and then it says that the ion equation shown. All right, so here you can study that because um, nickel, right, reaction with Pb2 plus to give Pb and Ni2 plus. All right, and then you can see the half ion equation says like it's obvious that nickel is oxidized while Pb is get reduced. All right. So here you need to find which one is a reducing agent. Okay, so reducing agents means that you have a species that undergoes oxidation. Okay, so here it is obvious that the one that undergoes oxidation is actually nickel. Remember, reducing agent is oxidation. All right, so oxidation means that losing electron or loses electron. Okay, so loses electrons means that if you do something, then the thing that lost from you is actually no longer on your side, meaning this nickel has lost its electron. So the nickel, the electron of nickel now on the opposite side. All right, so here already. So while Pb is actually reduction, so we call this one oxidizing agent. So this is actually oxidizing agent because it accepts electron. That's why the oxidation state of Pb decreases from +2 to 0. So this one is increases because initially you have 0 and then now you have +2. Remember that charge, okay, is actually the oxidation number. Okay, so charge. How do I get charge from periodic table? Just see the group in which group is located. So group 1, so it will have +1 charge. So the oxidation number for that ion, for example, Na plus, is actually +1. Okay, so Mg 2 plus, so +2. So just see that one. So the reducing agent is nickel, all right, not Ni2 plus because you transform from nickel to Ni2 plus. So don't get mistake, yeah, don't mix up. So Ni is actually the reducing agent because it donates electron. All right. Next is let me clear. So you are okay. What is the general term given to the reactions type in which electrons are transferred? Okay, this one. So electron transfer from one species to another species is actually reduction, and oxidation. So that's it. All right. So write the half ion equation for this one. So what can you see here? You have Pb becomes Pb2 plus. So just write Pb goes to Pb2 plus. So this is actually, they are different in terms of charge. You have +2 here and then you have no charge. So to balance, you introduce electron. How many electrons is 2? Because electron is -1 charge. So this one +2 charge. So +2 minus 2 is equal to 0. Okay. And then it's here, it's obvious that Ag increases. So Ag, okay, so plus accepts electron to give Ag. All right, so because this one is +1 and then electron also -1, right? Next is then how do we using these informations to arrange the reactivity of metals. All right, so if you see here, all right, so if I go up again, so it means that nickel able to displace Pb to give Na2 plus. It means that nickel oxidizes Pb while Pb get reduced to Pb. All right, so Pb2 plus get reduced to Pb, and then of course if we see here, Pb able to oxidize Ag, so Ag reduce. Okay, so Ag gains electron from Pb to give Ag. So it means that the stronger atom is actually nickel because nickel able to give electron to Pb, and well, here Pb able to provide electron to Ag to give Ag. Okay, so here we can write the most reactive is actually nickel. All right, the least reactive actually Ag, while in between is actually Pb. Again, yeah, because Ni provides electron to Pb, 2 plus to give Pb. All right, so Ni provides electron to Pb, 2 plus to give Pb. All right, so that's why the Ni is more reactive than Pb. All right, so the reactivity of metal is depend on the availability of that metal to provide electron. All right, so that's it. So the more available for any metallic atom to provide electron, the more reactive here. Okay, so the difference between the transition metal, all right, transition element with non-transition element is actually one has higher density. Okay, why higher density? If we consider nickel, for example, 24, so you have a 24 electrons, but then the charge is actually +2. All right, so the most common charge is +2. So it means that density equal to mass over volume. All right, so if the mass is increases with the same volume, then you will have a higher density. So mass in this case is referring to the number of electron of nickel. All right, so and then of course it has also high melting point. All right, I just write empty melting point. All right, okay, again, yeah, the higher or low melting point of metal, it depends on the strength of metallic bonding. Strength of metallic bonding. The stronger metallic bonding, the higher melting point. All right, and then this one also, it has a color. All right, so this is actually the colored compound. All right, so actually this is always be the main characteristic. All right, so when you look at this one, of course, you can see that we have a setup. All right, so we have a setup of electrolysis. So what we need to do is actually we see a power supply. So electrolysis by definition is actually the compositions of any compound by the action of electricity. All right, the compositions of any compound by the action of or by the help of electricity. All right, if we study this one, all right, if we study this one, so we can actually refine nickel by electrolysis. All right, so we can get nickel using electricity. All right, so how do we do this one? All right, okay, so as you know, cathode is always reduction. All right, so this is the place of reduction. Okay, so let me repeat. This one is actually the place for reduction. Reductions means that you gain electron. All right, so here a place for oxidation, which is losing electron or lose electron. All right, always remember that one, yeah, because you only have a single nickel, meaning that here nickel 2 plus 2 E minus to give an I, because it means that here you have a nickel 2 plus, and then how do you get this Ni2 plus? It is from any electrolyte. You can just put NiSO4, all right, or any electrolyte. Okay, an electrolyte is actually here is Ni plus and SO4 2 minus. All right, so you have a Ni2 SO4 2, but we use the simplest ratio divided by 2, so you'll have this form. All right, so it means that here you have a Ni2 plus, all right, Ni2 plus, and then you have SO4 2 minus. So because this one is negative electrode, so Ni is attracted to this negative electrode. So there will be like, if you see here at the cathode, okay, because it is actually negative electrode, so Ni will be, will be attracted to the side of this electron or this electrode, so making it because this one is actually, we have a negative electron. All right, so that's why we have this form, Ni2 plus 2e minus becomes Ni. But bear in mind, Ni that you have here is actually in the form of deposition. So there will be another layer here. There will be another layer after Ni2 plus transforms to Ni, then will be another layer for Ni. So that's why at the end of the electrolysis, mass of cathode will be increases. All right, because you have a solid here, depositions of solid from Ni2 plus. All right, next, what happened here? Because oxidation means losing electrons, so Ni becomes Ni2 plus 2e minus. So the Ni2 plus releases here. So, and while electron going out from this electrode, that's why it becomes positive. Understood, yeah? So the reason why this one is becomes positive because electrons gives away or electrons is liberated. So we have a metal here. All right, when the electron goes out, so when electron goes out, so it becomes ion. All right, so that's why we call this site, this anode is actually positive electrode, because this is actually the place where electron goes out, okay, from the strong metallic bonding to in the form of ion. All right, so and then last one is actually by indicate writing on N on the diagram where's the nickel produced. So I already mentioned to you that nickel is produced at the cathode. Okay, so here I just put right here N. Okay, why here? Because this is actually negative electrode. So, and then we have also Ni2 plus here, and then this in at this electrode Ni2 plus gains 2 electrons to give Ni S. So you have a depositions of Ni solid here at the cathode. Okay, I hope you learned something for today. Thank you for watching.